Okay, properties of metals. So, we've been given these properties of steel and Kevlar. And we have to explain two reasons why Kevlar is preferred to steel as a material for body armour for 4 marks. Okay, they stress that you're only allowed to give 2 reasons, okay? But then they say you have to explain them. So this is how we get the 4 marks, okay? You give a reason, then explain it. Give a reason, then explain it. 4 marks. So, let's start with density. The reason is that Kevlar is less dense, okay? Kevlar is less dense, okay? That's the reason. Therefore, okay, use the word therefore in these sort of questions, okay? Give the reason and then say therefore, because then you're showing the examiner that you're explaining it. Kevlar is less dense, therefore it's easier to wear, or it's more comfortable, or easier to carry. Or wear. Okay? 2 marks already. Let's pick on this one, relative strength, okay? Kevlar is stronger. Okay, we've given the reason, now we explain it. If it's stronger, therefore, okay, use the word therefore, it's better at stopping bullets, it gives better protection. Okay, there we go, 4 marks in the bag. But we could have also chosen either of these, okay? So we've answered the question, we've finished, we've got our 4 marks, but I just want to show you what you would write had you chosen this property or this one. Okay, I'm sure you get the idea. You just say Kevlar is more flexible, therefore it's more comfortable to wear. Okay, or you could have said that Kevlar is more resistant to corrosion. Okay, therefore it lasts longer. Okay, just pick any 2, all right, of those 4 for your 4 marks. Okay, this pen's running out. Suggest the next, no, the use of nanoparticles has increased in recent years. Okay, question about nanoparticles. So, they give us this cube of silver, which is 2 centimeters by 2 centimeters by 2 centimeters, okay? And they say calculate the surface area to volume ratio. All right, no problem. Right, what's the surface area? Well, each one of these, okay, each of the 6 sides of this cube is 2 by 2. Right, so it's 2 by 2 centimeters, that's one of the faces, but there's 6 of them for a cube. So total surface area is that, which is 24 cm squared. Okay. The volume is simply length times breadth times height, 2 times 2 times 2, which is 8 centimeters cubed. Get the units right. Area centimeters squared, volume centimeters cubed. Okay, so the surface area to volume ratio is 24 to 8. Can we simplify it? Yes, we can. 8 goes into 24 3 times, so it's 3 to 1. There we go. Nice easy 3 marks. Right, suggest an explanation of why a given mass of silver is more effective as a catalyst when used as nanoparticles rather than in powder form. 3 marks. Okay, with exam questions, they often give you a hint, okay? They're leading you through. There's a theme, okay? And the theme here is surface area to volume ratio. They've given you a massive hint with this previous question about the cube, okay? So, 3 marks. First thing, what they're getting at is that nanoparticles have a higher surface area to volume ratio, okay? So that's the first thing. So, nanoparticles have a bigger surface area to volume ratio, okay? And I will prove that to you now. Let's say we had a 1 by 1 by 1 cube, okay? 1, 1, 1. Let's quickly work out the surface area to volume ratio. So, the surface area is, it's 1 times 1 for each of the faces times 6, because there's 6 of them, okay, which is 6 centimetres squared. The volume is 1 by 1 by 1, which is 1, okay? So the surface area to volume ratio is 6 to 1. So same shapes, okay, same relative dimensions, it's a cube, but it's a smaller cube. And look what's happened to the surface area to volume ratio. When objects get smaller, their surface area to volume ratio increases, okay? It's gone from 3 to 1 to 6 to 1, okay? So when you get down to the size of a nanoparticle, which is much, much smaller than a cube, it's got a huge surface area to volume ratio, okay? You don't have to do this calculation in an exam. I just did that to show you mathematically. Just remember that the smaller objects get, the bigger their surface area to volume ratio gets, okay? And remember that nanoparticles have a very big surface area to volume ratio, okay? So a silver powder has, yes, it's made of fine particles, but it's important to realise that a powder, the particles in a powder are much, much bigger than nanoparticles, okay? Nanoparticles are nanoscaled, whereas like powder, you can just see it with the naked eye, individual particle, okay? So powder particles are much bigger than nanoparticles. So nanoparticles have a much bigger surface area to volume ratio than powder. Okay? So that's the first thing to say. Right. Next, I want you to remember this phrase, okay? Reactions, or chemical reactions, take place on the surface of the catalyst, or of the silver in this case. Okay? They take place on the surface. That's how these catalysts work. Okay? The reactants land physically on the catalyst, on the silver, react and then leave. Okay? So, next, you would say, therefore, what should we say? More molecules will come into contact with the nanoparticles per second. Okay? Therefore, more reactants contact the nanoparticles compared to the powder per second or per unit time. Okay? Therefore, how do I want to round this off? Yeah. Therefore, the reaction rate is faster. Okay? And that will get you your 3 marks. Right, so I'm going to say what I always say, because it's important, it's exam technique for these sort of questions. It was a 3-mark question, so we've said 4 things. Trying to say a little bit more if you can than the 3 things, if there's 3 marks available. And secondly, I've laid it out in this, therefore this, therefore this, therefore this kind of way. Use the word therefore rather than the word because. Okay? Don't say the reaction rate is faster because more reactants contact the nanoparticles per second, because it stops it dead. It's better to say therefore. Say more or rather, don't say more reactants contact the nanoparticles per second because nanoparticles have a bigger surface area to volume ratio, because you're going backwards. It stops it dead. Okay? Say this and therefore something and therefore something, because it keeps the flow going. It's just a better way of doing it. Okay, there we go. Finished.